Good evening again. Or whatever time it is in your town. In my town it is evening, it is Friday. It has been a long school week and I am tired, but I wanted to get some more factoring videos recorded. So this is going to be factoring polynomials when the number in front of the x squared is not 1, generally greater than 1. We're not going to mess around with fractions at this moment in life. This has multiple methods. Off the top of my head, I can think of at least four similar but different tactics. I am going to show you 2 of them, so this video will also include some factor by grouping. All right, I'm not going to show you tabular. I'm not going to show you the one that I call inside outside, which is kind of what I did in high school. They called it like a guess and check method, which I was not great at because the order is a little funny. But if you are interested in seeing a video on that, I can always do one. And I'm not going to show you the full like Xbox method. Just because I just think for like, I don't have no idea what words I want. Anyway, I just think it's going to be for best for right now. But like I said, if you are desperate for other factoring methods, I will show you more if you want. That is the cat. I don't know if you can hear her, but she's very loud and whiny. All right, so the first thing that I noticed about this is it's very similar to the idea of just a regular polynomial where I have to look at the last number. But the problem now is I want to still be able to split that 2x squared up. This is kind of where the guess and check method comes in, is this idea of I need to break that 2x squared up, so I'll need a 2x and a 1x, but I don't know what else is going to go with that, okay? Because I need to make a 12, I need to make a 5. So the first step that I normally do here is first I check for a GCF. Oh, GCF, what? Because sometimes what will happen is if you don't check for a GCF, there will be a GCF and you will have then just done a larger, more horrible problem. Or sometimes there'll be a GCF and then the problem is so much easier that you don't have to actually do the process I'm about to show you. So in this case, though, I have 2, 5, and 12. 2 and 12 are both divisible by 2, but 5 throws a wrench in the works, so the GCF here is 1. This has x squared, this has x, this is not carrying any x's, so I cannot factor an x out of all of those. So this is the GCF. So then my second step, and this is completely up to you, so if you're going to be doing grouping, my second step is a little different than if you're doing like a box or an unbox or a tabular or whatever. My second step here would be to go ahead and toss the first term into the box and toss the last term into the box. My first step for here, it's going to happen over there too, is I would take the 2 times 12. Now, why do I need 2 times 12, you ask? 2 times 12 because I have to take into account the 2 in front, what multiplies to 2, and what multiplies to 12, and how those will combine to add, subtract to 5. So I have to take 2 times 12 because that will give me the factors now for the middle term. So 2 times 12 is 24, and I'm now going to factor my 24. Because I am an anal retentive math teacher, I'm going to write every pair of factors, even if I don't need them. All right? You can't stop me. If you want to stop, then you stop. I don't care. But I like the factors, and I'm going to write them all out just because I said so. All right? 1 goes into 1 times 24, 2 times 12, 3 times 8, 4 times 6, and now I am finished because 5 doesn't go in, and if there had been anything bigger than 6, I would have found it already. All right, which pair of these now will give me positive 5? My little trick from the last one is that I add these together and I can get the positive or negative version of that. 1 and 24 is 25, so I can get positive or negative, not helpful. 24 minus 1 would give me 23. I can get the positive or negative, not helpful. If you're like, what in the God's name of the universe is she talking about? Go to my more simple factoring video to see kind of some basic factoring tips. This is the assumption that you already know how to do basic factoring and you're just like, why is this mean factoring so mean? All right, so 1 and 24 is not going to work. 2 and 12 will give me 14 or 10. 3 and 8, however, will give me the 5 that I need. I need a minus 3 and a plus 8. So for grouping, what happens now is that 5x becomes a minus 3x plus an 8x and then a minus 12. If you're doing the box version, the 3 and the 8 become your diagonals now that will combine to 5. Personally, I like box better because I think it's faster, but it's not better or faster if you don't understand it. All right, students always say to me, well, Miss City, what's easiest? The trick is what's easiest to me is not necessarily going to be easiest to you. So you want to find the method or methods that work best for you, because you are an individual human with a brain that works your way, and I have a brain that works my way, and my method isn't always going to be yours. So what you have to remember with grouping then is you have to remember, first of all, to group them. You generally want to group in twos. If they feel like they're not going to work nicely or you're worried about the way they're set up, you can always exchange the middle two. Generally, though, you can just have them in either order. If it fails you, though, you do want to rearrange them. The middle sign has to be a plus, and then the sign here has to go in with that secondary number. So if that was a minus, you can't say minus here. You have to say plus, and the minus is really a negative attached to that 8. Watch out for it, because if you don't watch out for it, you will not be able to finish your factor by grouping. All right, so now from here, what I do is I GCF, which I have a video on if you want to watch it. I GCF out of the box here. Not the box, that's not a box, that's a parentheses. 2 and 3 are both divisible by 1. X squared and x are both divisible by x. So you can write the 1 or you can leave it off. It still means 1x. When I divide 2x squared by 1x, I'm left with 2x. When I divide negative 3x by 1x, I'm left with negative 3. Okay, now I GCF out of the second parentheses, not box. 8 and 12 are both divisible by 4 as their GCF. Be careful, a lot of times you'll find a factor, but in order for factoring to work, you want to find the greatest factor. It's the greatest factor. Anyway, so I'm going to factor out 4. It's a positive 4, so when I put it here, I'm going to put a plus 4. And then 8x divided by 4 is 2x, and negative 12 divided by 4 is negative 3. And then do you notice that these two parentheses are the same? Now, this is the part when I teach grouping that throws students off. Like if anything's going to throw them off, if they've made it to here, this is the weird part. I am going to technically GCF again here, and I'm going to look at these almost as if they're still separate pieces. So what I'm looking at is, what is this red parentheses have in common with this red parentheses? You will notice that the red parentheses have the black parentheses in common. So I'm going to factor out the black parentheses. It doesn't have to technically go in front, but I like to write it in front because it seems to help students to think, okay, I factored that to the front. When that happens, this goes away because I factored it out, right? I said, oh, you got factored. So what's left is that 1x. This one also got factored, so it reduced, and I'm left with the plus 4. And that is my answer. If you want to check your answer, you multiply it back together using FOIL, distribution box, whatever makes you happiest. I have a video on that too, if you want to see it. Now, box method is going to give you the same answer. I'm fighting a lamp. Lit.
Are you winning?
No. Sweet.
I'm sorry.
Okay.
Success.
Sort of. Okay. With box method, I had a complete brain blank there.
Sorry.
With the box method, you're going to get the same answer, but the difference here is you're going to factor out of the box. I just personally, like I said, I just like this better because I think it's a little bit more organized, and I think it's faster for me. But if it's not faster for you, then it's not the best method. Okay, so I'm just going to look here and say 2x squared and 8x can both be divided by 2x. Notice this one starts with a negative. That means I'm going to factor out a negative. That tip is from my other factoring video if you want to check it out. And then these have a 3 in common. Now I'm going to factor upwards. And it doesn't matter what direction you factor. Like when I look and see like tabular, they factor this direction and then up. It doesn't matter. Just be consistent. I have a tendency to factor this way and this way. Just because I can. Okay, these two, they don't have anything but a 1 in common. And then they have an x in common. Notice the 8 is positive, even though the 12 is negative, because the sentence starts positive and everybody likes positivity. It's going to be a plus. And then these two, when I factor, their greatest factor is a 4. When I write the answer, I get 2x minus 3 times 1x plus 4, which is the exact same answer I got with grouping. Or you can always flip them and it's still the same answer. Okay? So the order of the way you write your answer doesn't matter as long as you keep this piece together and this piece together, or if you want to think of it as like this, the parentheses GCF together with the leftover pieces together. I want to do one more of this style in this video because I want to show you one where you need to GCF first in order to make it like a more feasible problem. So, but like you don't want to do both of these, like unless you're really in love with math or you like to do multiple methods to check yourself, which I actually have students like that. You would pick one of these. You would do grouping or you would do box. And I would say that if at this point you're not sure which you like, try them both out and see how it goes. If you try them both and you don't like either of them, you can leave me a message or a comment or whatever, and I'll show you another method because there are more. You could probably YouTube search other factoring methods and someone somewhere has done them. All right, but if you're desperate to see me factor more stuff, then you can always ask. All right, so I pulled one from a book because these are a pain to think of on your own. And it is 2x to the 4th plus 3x to the 3rd minus 9x squared. Let me make sure I got that correct. Okay, you can definitely create these on your own, and I can create them on my own, but on a Friday after a long week, we're just better off stealing from a college algebra book. Okay, so step 1, GCF. Notice 2, 3, and 9, their GCF is 1, but I have here 4 x's, or x to the 4th, 3 x's multiplying, and then 2 x's. I had a video about factor by GCF, but if you're like, I will very quickly talk about it again here. The idea here is you want to take equally from each pile. Not that you want the piles to be equal, but you don't want to take more from like the smallest pile than it has. So the idea here is this has 4 x's, and I would love to take 4 x's, but I can't because this one only has 3 x's. So if I try to take 4 from here, this guy will still owe me 1. Now I would love to take 3 x's even, but I can't because if I take 3 x's, this guy will still have some left, but this guy will owe me. Okay, so the idea here is you're going to take the most you can take from the least amount. So I could take 2 from this person or this pile or wherever this is, and I could take 2 from here and 2 from here. So I'm taking equally from each, and I'm not overtaking. Okay? So the GCF here, and if you want a better explanation, go watch my other factoring video. All right, and then do your math homework. Okay, I'm going to factor out an x squared. You don't have to write the 1 if you don't want to. I don't want to, and you can't make me. All right, so now that x squared, and this is the important part of GCF at the beginning, that x squared made the problem smaller and more palatable. It also is to remind you that now that I've done that, I am not going to do anything at all with this until the end. So I'm going to do my whole factoring processes completely ignoring that x squared. Not that I don't love it, and I'm not going to come back to it, but I don't need to deal with it right now. It's like sitting in a corner eating a lollipop, and I don't need to pay attention to it at this moment. Okay? So I'm going to do box here because I don't want to do grouping again. But if you're like, Miss Sittig, I need to see grouping again, let me know and I will do a video on just grouping. All right. So I'm going to do here, I'm going to take the 2 times the 9 like I did in the last problem. Remember, I need to break the 2 up and I need to break the 9 up. I need them to multiply to 2 and multiply to 9, and then those pieces add, subtract to 3. So 2 times 9 in my town is 18. Okay. I'm tired and I can't do math anymore. 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, and I'm finished because if there'd been anything bigger than 6, I would have found it. Now I'm going to take those factors and find the 3. In this case, it'll be the 3 and the 6. 2 and 9 will make 11 or 7. 1 and 18 will make 19 or 17. So those do not work for me. But if I have a plus 6 and a minus 3, that will work. You can group here if you'd like. I'm going to box. So I really should have done my box earlier so I knew which pieces to put where. But remember, your first term goes in your first box, and your last term goes in your last box. And then the 3 and the 6 go on the diagonal. It doesn't matter which one goes where. You need to include their x's. In real life, you probably shouldn't include your x because that usually creates chaos. but in math, it's okay to include x's. Now I'm going to factor out of the box, and I'm going to use blue. All right, 2 and 3 only have a 1 in common, but they share, this one has 2 x's and this one has 1 x, so I can factor out an x. This one starts positive, so it doesn't matter that that's a negative because it starts positive. We're going to keep the plus, and then they get a 3. Oh, look at this. Now I'm going to factor upwards. They have a 2 in common and an x. This started negative, so I take out the negative, and they've got a 3 in common. So, allegedly, my answer will be 2x minus 3, x plus 3. Or, flip those two beautiful blue things, and you get the answer. You can double check by multiplying back into box. You could even check over here. X times 2x gives me 2x squared. Perfect, that's what I needed there. X times negative 3 gives me negative 3x. Perfect, that's what I needed there. 3 times 2x gives me positive 6x. And then 3 times negative 3 gives me negative 9. Okay, so this is factoring polynomials when the number in front is not 1. I ended up with 2 of them that had 2's to start with. But the process is the same even as the numbers get bigger or weirder. Once again, if you're like, great, Siddig, that was really helpful, except what if the number's big and horrible? Leave a comment, and I will do one where the numbers are big and horrible. One other trick or tip to factoring in general, and this does not have to do with this specific problem, but say this problem, oh, Siddig, what did I forget? Do you remember what I forgot?
Lollipops?
Yeah, I forgot poor little lollipops in the corner. Don't forget to add lollipops back into the front because my answer wasn't this, my answer was that much bigger. Poor lollipops, I'm sorry. Maybe I don't love them after all.
Shh, don't.
Anyway, okay. What I was going to mention to you though is you don't have to do this. I have a student right now that does tabular and doesn't bother taking the negative out, which is totally fine. But I have generally found as a teacher, and you don't have to do this, but this is just a recommendation. Say this had started like that. Even if there was nothing else to factor out, generally it is more painful to factor when you start with a negative. Okay, I generally, like negatives when they start things just make math a little bit more complicated. So I would recommend that when you factored out the poor little lollipop who I forgot, also factor out that negative, because then when you get to the problem, you're only dealing with what this sign is, and you're not concerned at all about what the sign in front is. Because then you have to worry about whether the negative goes on the 2, whether the negative goes on the x, because then it has to work with the rest of the numbers. So just like as a bonus FYI, factor the negative at the front out. Only if it's at the front. You don't want to start a sentence negative. I always tell my students, like, how would you feel if somebody like walked into a classroom and was just like, you're the worst? You would not be happy to see them because they started off with a negative. So you don't want to start a polynomial with a negative either, unless you're a jerk. And that was edited for YouTube because I was going to say a swear word. All right, so hopefully this helped. I have more videos on the way. If you have something that you would like to see, comment. I don't know, this is so weird. I don't know why you would like a math video necessarily, but if you want to like my math videos, you're more than welcome to. And if you feel like it would help you to be subscribed to my channel, please do so. Have a lovely evening, day.